Okay, so we're going to Desmos. Again, the link is on Google Classroom on today's agenda, or you could just go to Desmos and type in this function. Okay, we're looking for how many intercepts do we actually see, what are they, and we're going to make a little sketch over here in just a second. Intercept. Okay, turn and talk to someone near you. How would you describe my x-intercept at 1? Turn and talk with someone near you.
How would you describe that?
What's happening on that graph? Wow. What's happening?
They have
What's up? It's a turn. Good. How would you describe that x-intercept? All right. What's happening at this x-intercept? What's happening here? Why is it special? It's tangent to the x. Can't believe you used that word. That's fantastic. Yeah, it's touching the x-axis. It's tangent. It's touching the x-axis. Leslie said it's a turn. It counts as one of our turns. Okay, it's touching the x-axis. What about the other x-intercept? How would you describe it? It's going through. It's going through our x-axis. Okay? Let's go back to our paper and let's just make a sketch. Okay, so it's going up. Our highest point right here is about 9.5. We've got our intercepts. It's going to infinity. It was coming from negative infinity. So let's sketch it in our lesson packet, if you haven't done so. Okay. It's touching at 1. It's going through at -3. And it reaches about 10. Okay, the important parts here. It touches the x-axis. It does not go through. Okay? What are our x-intercepts? +1, -3. Part D, it says the equation can also be written in this factored form. What are the zeros or the roots or the solutions for this factored equation? If I look at that factored form, what's unique about it? If I look at the factored form, what's unique? What's different? It tells us our x-intercepts.
Why is there 2 of the same?
Fantastic question. Why is there 2 of these? There's 2 x minus 1s. Because that's how we get an x-intercept. An x-intercept that touches the x-axis. How could I rewrite 2 of them? How could I express that? Instead of writing 2 of them next to each other, they're multiplying. How could I write 2 of them? In a simpler way. Squared. Yeah. So it's really x minus 1 squared, x plus 3. So how many zeros are x-intercepts? There are only 2. Okay? There's only going to be 2 that are real. How many imaginary do you think there's going to be? If it's a 3rd degree. Michael's saying 1. Because it's a 3rd degree, there will be 1 imaginary. So, because we started with a 3rd degree function, or polynomial, the number of solutions, or zeros, needs to add up to that highest degree. I have 2 real, I have 1 imaginary. Okay, we're not going to find the imaginary yet. We're just looking for some patterns. Right now, I want you to use your Desmos graph, and I want you to do number 2. Number 2. when you're on the Desmos graph that I made for you guys, if you just click it, if you unclick the red one and click this one, you can just look at the second one. So right now you're answering questions about number 2. Okay. What questions do we have about the graph so far? You've got 3 x-intercepts. You would expect 5. If we look at the factored form, think about this being x squared, this being x squared, this being x to the first. How many x's would that add up to be? X squared times x squared times x to the first. Think about our rules of exponents. X squared times x squared times x to the first. What would that add up to be? 5. So do I have any imaginary solutions here? No. I have all of my real solutions. Okay? So we have 3 real solutions. There are no imaginary ones because these two touch at -3 and then touch and bounce off the graph at +1. Okay, so when we look at factored form, it's important to also look at the exponents. The exponents on each factor. Questions about that? Are we seeing exponents on the factors now? Number 3, how can you tell from the graph of a function how many times a 0 occurs? So for example, my 0 for x plus 3 squared, that would technically tell me that I have 2 answers that are the same. So how can I tell just by looking at the graph how many times a 0 occurs? Any ideas, thoughts? Okay, if the graph crosses the x-axis, if it crosses the x-axis and goes through, then the 0 occurs once. What if it bounces off the x-axis or touches it? What would that be? 2 squared. So we'll write that. If the graph touches or bounces off the x-axis, then that 0 will occur 2 times. What questions do we have about those relationships? In Desmos, before we do the quick notes, I just want to type in another equation with you. Is anyone still writing this? Okay. Let's just go to Desmos and let's all type in, what if instead I type in factored form And let's say I want to make a factor touch the x-axis at -1 or positive 1. What would the power have to be? I want it to touch. What, Talon? Square. So let's do x minus 2 squared. Okay, and what if I want another x-intercept at -3? Now I have, what's the degree of that function? By looking at it. What's the degree of that function? Pause. So add that. Let's look at the graph. So now it's a 3 plus 1 plus 2. What's 3 plus 1 plus 2? What's the degree of that function? 6. It's a 6th degree. So it has even behavior. Let's zoom in. Zoom in here on your x equals 2 intercept. What do you notice is happening at that specific x-intercept when I cubed it in the factored form? What's happening? How would you describe it? It went through. It went through the graph. Zoom in more. Zoom in more. What's happening? It goes through, but it almost flattens out here. Do you see that relationship? It's not just going through. So we've got to bend. We've got to bend. So make a note. When I have something to the power of 3, it's going to have a bend before it goes through. Okay? And that's going to occur with odd degrees on our factors. So if this were a 5th degree, it would bend. Again, if this were a 4, this would also bounce or touch the x-axis. Questions? Okay, we're going to do our quick notes. So shut your Chromebooks. Quick notes. Shut your Chromebooks. Yeah.
Will be done before 11.
Before 11? Yeah. Well, we're done at 11:05.
I know, but as you go to the library for consent, you know, do they want to do?
Okay, here we go. The first thing we're going to talk about is the zeros. The zeros. We also call these roots. And we've got 2 categories. They can be real or imaginary. They could be real or imaginary. And we're going to focus on the factored form. So let's say I have this factor where k is the x-intercept and n is the power. 2 things are happening here. If n is odd, the graph will cross the x-axis. At that x-intercept. What about if n is even, like 2, 4, 6? What do we notice at that x-intercept? What does it do? What does the graph do? If it's even, it would bounce or touch. Okay? And then we're going to come back to imaginary roots. Okay? You can't see them on the graph. You can tell they're there if you've got like a fourth degree, but you can only see 3. So think back to your degree. Can you see 4 x-intercepts? If not, maybe one is imaginary. Again, we're going to look at this form where I have A is the real part and BI is the imaginary part. This is a complex number. Okay? Its conjugate is going to be A minus BI. We call that a conjugate. It's a conjugate parts. It comes from square rooting, the plus or minus. The plus or minus of the square root. What questions do we have? We're going to practice I again in the check for understanding. We're going to do the check for understanding. I'm going to give you your exit ticket, and then we won't have any homework. Okay? Anybody still writing? Ready? Factored form. So here are the zeros. It's telling me that 4 has a double root, which means it'll have a square. So let's start with our factors. I'm going to use my A value. If my first x-intercept's -2, what's the factor? X plus 2. And if my second x-intercept's +3, what's the factor? Good. And then 4 is the double root, so it'll be x minus 4, but it'll be squared. So when it has a double root, it means there's 2 of them. Okay? Now we're going to solve for the A value. It tells us the y-intercept is 192. Remember, your x is always 0. So now let's solve for our A value. So I'm going to replace y with 192. Replace x with 0. Let's see the A value when we simplify. So remember, always do the parentheses first, then exponents. So what's 0 plus 2? 2. What's 0 minus 3? Okay, what's 0 minus 4? And then I square it. -4, and then I square it. +16, good. +16, and now I'm doing 2 times 3 times negatives, or +16. We do have one negative. What do we get next to A? What'd you get? -96. So then when I divide both sides, we get A is -2. And I can put that back in my original factored form equation. Questions? We're just adding in that now I can have a squared factor or a cubed factor and what it does to the graph. We're going to do one more. We're going to do one more because it's got an imaginary root. Are you ready for the imaginary numbers? We can do it. We can do it. Let's recall. I squared equals what? -1. Great. It says we have a missing 0. So I have 5i. The conjugate would be a -5i. So that's the third root. They only listed 2 for us. And now we're going to write it in a possible factored form. If one of the roots is x equals 2, what would the factor be? -2. If one of the roots is a +5i, what would that factor be? -5i. And then my next one would be +5i. So I'm just taking my x-intercepts or my roots, and I'm working backwards. The biggest difference is now I've got I. So now we need to write it in general or standard form. What do we think we're going to do to multiply this out? Box. And when you guys box, multiply the I parts together first. Does that make sense? Deal with the I's first. We're going to box. You ready? We're going to box. x minus 5i times x plus 5i. What is I squared equal to? -1. So I'm going to ignore those boxes. They cancel out. I'm getting x squared, and you're telling me I can replace this with a -1. So then what's 25 times a -1? Okay? We still have one more factor. So what do you think we have to do? Yeah, you're right. One more box. So we're going to do x squared plus 25 times x minus 2. X cubed minus 2x squared, 25x minus 50. Questions? Oops. Okay. What questions do we have? It says graph on your calculator. We would do it on Desmos. Why can't you see all 3 zeros? Why can't I see all 3 zeros? 2's imaginary. Yep, 2's are imaginary. Questions? All right, we're going to do our exit ticket.